Hi there. In this video, I'm going to show you how to use Avogadro to make a file containing your molecule of interest that you would like to dock into your protein. In this image, you see two structures. The one below is D-luciferin, which is native to firefly luciferase. And above, we have a molecule called 4-bromoluciferin, which is very similar to D-Luc. It just has this modification at the 4' position. So what we want to do is we want to dock these two molecules into firefly luciferase and see which one it binds better. That is just an example of things you can do with AutoDock. You could imagine a similar process that you might want to do on the TAC team if you have different 2' modifications as part of your nucleotides. You might want to see how those dock into different TAC mutants. But yeah, we're going to stick with this luciferase example. So you need a PDB file of your substrate to dock into the protein, and that can be pretty easy to find if you are dealing with the native substrate. However, if you're dealing with a synthetic substrate, meaning it has some modifications, you're going to need to create this molecule from scratch in Avogadro. So how you go about drawing a molecule, you just start by clicking, and whatever molecule appears is dictated by what you have set here. So we're going to start with making some carbon structures. Here, we'll start with this section right here. So we're going to have this carbon correspond to the carbon right here. Now there's another carbon it's attached to, and we get that other carbon to appear just by clicking, but we want to attach them. So, whoops. Yep. So you just kind of draw a line from one to another, and then when you want to change the atom, the next one we see is nitrogen. Just click this once, and then you draw a line, and you keep going, adding this carbon right here. We're going to do the same method of just clicking and dragging. And next is sulfur. And again, we just click it and drag it to the adjacent atom. So don't worry if this doesn't have the exact bond angles of your substrate. That gets fixed a little bit later. And you might notice that there's a single bond right here when it should be a double bond. It's pretty easy to change. You just click double bond and click where you want to add that double bond. So I went and just filled in the rest of the molecule. I tried my best to make it look exactly like this structure here, but obviously the angles are kind of wonky, but that doesn't really matter. The only thing that matters is that you have the right atoms in the right places. So now that we have the structure that looks like your substrate, we need to fix these angles. So how we do that is we go to this auto optimization tool right here, and we just use these default settings and press start. So what this does is it samples different conformations of this molecule, so it finds the correct energy minimum and sets that to be your structure. And you can pretty much just wait till the DE gets to 0. So now that we have this molecule, we can check to make sure that it looks like our substrate. The important thing to check is stereochemistry. So here we see that the carboxyl group is going into the page, and we see that that's preserved in this structure. So the structure that we generated matches our substrate. So now all we have to do is save the file. You can call it whatever you want. And when it comes to file type, there's a bunch of different files you can choose. They all serve different purposes for different software, but we want to use PDB because that's compatible with Autodoc. And now you have your energy minimized structure that is in the proper format to be loaded into Autodoc.